And we are talking relations versus functions. The first vocab word that we have here is a relation. A relation is when we pair two sets of numbers together. So basically like x's and y's. If I have x's and I have y's, I have a relation. There are two parts of a relation that we're going to focus on. The first part is the domain, and I'm going to color code this a little bit. The domain represents all of the inputs, aka the x values of a relation. Whereas the range represents all of the outputs, aka the y values within a relation. So we got to remember that domain goes with the x's, range goes with the y's. Then we talk about functions. A function is a relation where each input, aka x value, is paired with exactly one output, aka y value. So all functions are types of relations, but as we are going to see, not every single relation that we talk about is a function. A way that we can determine whether something is or is not a function is using a mapping diagram, which maps each input to its output. And again, like I said, this is going to help us identify if a relation is or is not a function. That's a lot of words. Let's see what I mean by those. So one of the ways that we are going to see our groups of data is as coordinate pairs. We know that a coordinate is like a point on a graph, right? There's an x value and there's a y value for every single coordinate. I'm going to color code these just a little bit. I'm going to underline, here's all my x's. X, 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 X. And then the other half, the right side, those are the y values. We know how points work, right? Okay, so in this problem, I have three things that I'm going to do. The first thing I'm going to do is determine what is the domain and what is the range. I have three rules that I'm going to follow when I talk about domain and range. I'm going to write them off to the side here. When I list out domain and range, I can't just put a bunch of numbers down. It has to follow these three rules. Number one, I am going to list them from least to greatest. Number two is I am not going to repeat any of my values. And number three is I am going to list them separated by commas inside some curly braces, which are just fancy squiggly parentheses. Okay, so if I'm looking at the domain, which is this first part of letter A, remember that domain represents all the x values, so I will take every x that I just underlined in that set of values, and I'm going to list them in these curly braces, separated by commas, from least to greatest without repeating the same number twice. So the smallest number on there is a -6. Then I have 1, 2, 3, 4. No repeats. They're listed from least to greatest, separated by commas with the curly braces. That's it. That's my domain. I can do the same thing now for the range. Range is always associated with the y values, so I'm going to do the same exact thing. Curly braces. I'm going to start with the smallest value, which is -4. The next smallest value is 3. Do we see how there's two 3s here? There's a 3 and a 3. We want to remember, we are not going to repeat that 3 twice. We're just going to write it one time. That's it for domain and range. That's part one. Everybody good there? Now we have to figure out, do these values represent a function, or is it just a relation that's not a function? The way we do that is using a mapping diagram. What's nice about doing the domain and range first is that my mapping diagram is going to come from those values that I just put in my domain and range. So I'm going to have one bubble represent the x's and one bubble represent the y's. And from my domain, that -6, 1, 2, 3, 4, I'm going to put those values in here. And from my range, -4, 3, 5, 6, I'm going to put those values in here. Everybody with me? I'm not doing rocket science. Now, the next thing I'm going to do is the mapping part. I'm going to look at these points, which each represent a pair of an x and a y, and I'm going to draw arrows from the x's to the y's. So the first point is 4, 3. I'm going to connect up the 4 in the x column to the 3 in the y column. And I'm going to do that for all 5 of my points here. So 2 to 6, 3 to 5, -6 to 3, and then 1 to -4. That is what a complete mapping diagram should look like. All the x's are listed, all the y's are listed, and I've drawn arrows from x's to y's. Good there. That's part 2. The third part now says, now that I have a mapping diagram, I got to determine, is this representing a function, y or y not? Let's look at my definition of a function again really quickly. It says it's a relation where each input, the x's, has exactly one y value. Not more than 1, not less than 1. So if I look here, does every x value point to one y value? It does. My rule that I'm looking for is that if I'm looking on the left side here at the x's, there is only one arrow that's starting at every x value. I should not have more than one arrow coming from the x values. We can see here, there's 2 arrows that point at 3, but that's okay. I don't care where the arrow ends as long as there's only one arrow starting at each x value. Okay, so because there is only one arrow starting from each x value, I can answer my question. Let's zoom in a little bit here. Is the relation a function? Yes. Because, and you're going to pretty much write this exact same sentence for every single one that is a yes. You're going to say each input has exactly one output. Oops, if I could spell. And that's that. Can I go a little faster on the second one? We think we got it. 3 things that we have to do. We're going to start by looking at my points and identifying the domain and the range. Let's take a look at letter B. Domain represents what? X's or Y's? Where am I looking? Chaz. Yep, domain, I look at the X's. So here's all the X values. I am not going to repeat this -3 because it shows up twice. I'm going to write it exactly 1 time. And I'm going to list them from least to greatest. Which means the range should be looking at all the Y values from least to greatest. And that's part 1 done. That's all I got to do there. Now, let's map them. I'm going to put my X's on one side. I'm going to put my Y's on the other. And I'm going to connect up those pairs. So -3 points to 5. 10 points to 3. -3 points to 1, and 4 points to -6. Everybody got that? Is this a function, yes or no? Why not? Chess. It's not necessarily that there's a missing input, but do you have a better explanation? Yeah, -3 has 2 outputs. Do we see how there's 2 arrows starting from that same number? We cannot do that. So we would say no, because -3 has 2 outputs. We should never have something with 2 outputs. Does that make sense? Okay. They do try to trick you, so just be careful. We're looking at those arrows. All right, flip it over. We're going to do the exact same thing, essentially. The only thing that is different between those last 2 problems and these 2 problems is that we're not looking at points. We're looking at a table, which doesn't really change very much. I still have pairs of x and y values. So on the left side, there's all my x's. On the right side, there's all my y's. I can still identify my domain and my range. Remember, domain looks at those x values. So let's fill that in. What goes in here? What's my domain? Anybody want to give that one a shot? Jaden? Perfect. We're not repeating that -2. We're just writing -2 one time. And then what about my range? Who wants to do range? Chess. Perfect. Oops, I keep doing that. Curly braces, not parentheses. Your curly braces don't have to be fancy. Mine are literally just squiggles. All right, let's map them. I'm going to put my x's on one side. I'm going to put my y's on the other side. And I'm going to connect them. Now, what's different here is they're not written as points, but we understand how a table works, right? Like the top row is a pair. -2 goes to 7. 6 goes to -3. -2 goes to 8. 5 goes to 6. 0 goes to 0. What do we think? Function or not a function? Why? -2 this time has 2 outputs. I see 2 arrows starting from -2. That's a no-no, so I say no. -2 has 2 outputs. Oops. Okay, try the next one. Same deal. What's my domain? Branson? Perfect. Range? Chaz? Perfect. Did we get those in our mapping diagram? What did we discover? Function or not a function? Jaden says yes. Everybody agree? We have a function here. Let's see what happens. -1 pairs to 3. 6 pairs to 3. Is that okay? Can I have 2 numbers pointing at the same output? That's fine. 2 goes to 4. Or sorry, +2 goes to 4. -1, can I have another arrow starting here like this? Can I point it at 3? Is that okay? Is that 2 different arrows pointing away from -1? It's the same arrow, so that's fine. These 2 are the exact same pair, so I'm cool with that. And then -2 to 2. So again, I don't have any arrows that are starting from the same spot. So yes, each input, if I could write, has exactly 1 output. Are we satisfied with that? Okay. The last thing I'm going to show you, we've done points in a table. We've done points just written out in a list. Now I'm going to show you points on a graph. How do we figure out if something is a function? And it's very, very easy. We have this test called the vertical line test, or VLT, which states that if I take a vertical line, which we know a vertical line goes up and down, right? Okay. A vertical line, if it goes across my graph and it passes through more than 1 point on the graph at a time, then we fail the vertical line test and our relation is not a function. So in order for a relation to be a function, we have to pass the vertical line test. So I'm going to show you what this looks like. So you can do this with a pencil, with your finger. I'm going to do it with my giant yardstick over here. And I'm going to have my vertical line straight up and down. And I'm literally going to put it up to my graph. And I'm going to go, okay, I'm trying to see if there is any time that 2 points touch my vertical line. So I go across. Hey, look at that. At -4, I touched 2 different points at the same time. That's an automatic failure. That means this is not a function. So because of this right here, not a function, it fails, and I'm going to abbreviate here, it fails the vertical line test. That's all you have to write. Good? Let's try again. Take your finger or your pencil. Let's look at letter B. I'm going to go across this graph with my vertical line. Do I ever touch this graph more than once? No. So does it pass the vertical line test? So it's a function. Passes. VLT. Lastly, passing or failing? Failing. It fails all in here. It overlaps like 3 times. So is the relation a function? That's all I got to say. Any questions on that?